In this problem, which series diverges? Let's start with the blue one. As n approaches infinity, this fraction approaches 0, so our terms are approaching sine of 0, which is 0. So our terms are approaching 0. That doesn't necessarily mean the series converges, but I suspect that it does. So let's do a comparison with another converging series. How about the converging p series when p is equal to 2? Using the limit comparison test, the limit as n approaches infinity of our term divided by the known series term reduces to this, and as n approaches infinity, this expression is infinity times 0, which is an indeterminate form. However, we can't use L'Hopital's rule until we write it as a fraction. So we'll rewrite the n squared in the denominator as n to the negative 2 power. And now we have the indeterminate form 0 over 0. So we use L'Hopital's rule, take the derivative of the numerator and the derivative of the denominator, and these factors cancel each other out, so very nicely it's approaching cosine of 0, which is approaching 1. Since 1 is a positive value, then by the limit comparison test, our series converges. So Roman numeral 1 is not one of the series that diverges. Let's check out the red one, Roman numeral 2. This one is a lot more clear that we should probably check this series compared to the geometric series 3/4 to the n. So this is a geometric series that converges, and using the limit comparison test, our terms divided by the known series terms simplifies to this, and as n approaches infinity, that's 1. So once again, by the limit comparison test, this series converges. That leaves us with the green one. All right, as you look at the green one, if we're going to do a limit comparison test, we want to compare it to the p series that it most closely resembles. So the biggest power of n on top is n to the 1, and the biggest power of n to the bottom is the square root of n to the 3rd, or n to the 3/2. So simplify those leading terms of the numerator and the denominator, highest degree terms. This is to the 2/2, so when we subtract 2/2 from 3/2, we're left with 1/2. Okay, this is a diverging p series. So we're going to compare our series to the diverging p series, where p is 1/2. Using the limit comparison test, our term divided by the known series term simplifies to this, which simplifies to this, and this is the indeterminate form infinity over infinity. So we could apply L'Hopital's rule here. We'd have to apply it quite a few times, and it's a lot of work, but this is a multiple choice question, so we don't have to be mathematically rigorous with L'Hopital's rule. We can just use the big number logic and just focus on the biggest term of the numerator and the term with the biggest degree of the variable in the denominator, and ignore the n to the 1 power and the 3n squared under the square power. Ignore those. As n approaches infinity, those things become irrelevant, so we can just focus on these, and that's equal to 1, which is a positive value, and therefore by the limit comparison test, our series diverges. So only the green one diverges, and that was choice B.